Find the domain of the following. Again, the domain is all your x values, your inputs, okay? We have a restricted domain when we have a fraction or a radical, correct? So, how do I know the bad point? I'm looking to see when this fails. We could graph these. I think it's pretty easy algebraically. I want to know when the bottom equals 0, because that's a bad point, okay? So I add 4 to both sides. 2x equals 4, divide by 2, x equals 2. So when x equals 2, this goes to 0, which is undefined, so we cannot equal that. Any other number is our domain. Okay? So our domain would be negative infinity to 2, parenthesis, cannot include, union 2 to infinity. And that was a review of what we did on Wednesday. It's been a while. Okay? How many people graphed it? You'll have a hole at 2. Remember the line? Okay? Now the other time where you have to restrict your domain or you're going to have problems is in a radical, because remember, we're not going to be taking the square root of negatives. So whenever your radicand goes negative, that's bad. And I do believe I told you on Wednesday is the way I do it is I set it up to be less than 0, because that's a negative number. So then I subtract 1. 1/2 x is less than negative 1. Multiply by the reciprocal. So x is less than negative 2. Can it equal negative 2? Can this equal negative 2? What's 1/2 of negative 2? Negative 1. What's negative 1 plus 1? What's square root of 0? So I can equal that. That's why I did not put the equal to bar here. So what would my range be then? Anything less than negative 2 is bad. Sometimes people don't know which way to go. And they get confused. They don't know if the less thans are problems or is it the ones greater than negative 2 is the problem. So what I always do is pick a number that's greater than negative 2 to the right side. What's the easiest number we could pick? 0, right? What's 1/2 times 0? 1. Can I take the square root of 1? 1. So these are all the bad numbers. Less than negative 2. So what would my domain be? Bracket negative 2. And that is the answer.
Is it a bracket or parentheses?
Cannot be a oh, I'm sorry. Woo, woo. Good call, Aaron Roche. You're on top of it. It is a bracket because why? It can include it. And that's what we did for domain. Do we need another one? Yeah, let's do one more. Why not? Let's go with h of x is equal to, you want a radical? Yeah, let's do a radical. Let's go crazy since it's a Monday. 3/7 minus 4x. I want you to find the domain. Again, this fails when it's less than negative. I've always been doing less than, so we see what it looks like when we say, let's go with greater than 0. That would be all the right answers. If you want, we can do it that way too. 3/7 minus 4x greater than 0. Or equal to 0. Okay? So I'm going to minus 3/7 minus 3/7. So I have negative 4x greater than or equal to negative 3/7. I'm going to divide by negative 4, so I have to flip the sign. And I'm going to get negative 3 positive 3/28. Hey, where's Mochko today? Oh,
He's sick.
buck fever?
No, he actually has a high fever, 100 and something.
Okay. So, all the answers less than 3/28 should work. Does that make sense? And just in case you don't know, before you're confused on selecting your domain, we could always just pick a number like, what number's less than that would work real well? 0. So, 3/7 minus 4 times 0. What's 4 times 0? 0. So we're okay. Excuse me. So all the numbers from negative infinity to 3/28 included, excuse me, work. That good? Excuse me, I'm choking for a minute. All right, let's find the range. The range can be very, very difficult doing algebraically. For this classroom, we will only do it graphing. That's all we're going to do. Okay? Now, a quick refresher before you start doing these. When we had a graph that looked like this, the domain, we wanted to know how many x values would work. And these go forever each direction. So what would the domain of this be? Okay, the domain would be negative infinity to infinity. Now let's look at the big R, the range. All the y values that it's going to equal. Basically, you're just drawing lines to the graph. Is there any holes in that line? Will every y value be representative here? So that also is negative infinity to infinity. So just knowing what you know about graphing, can you give me the range of this right now without even looking? You should be able to say, well, my y-intercept is up here at 5. 1, 2, 3, 4, 5. I go up 3 over 1. My range goes forever. So my range would be, remember, negative infinity on the range is down here, positive up here. Okay? So graphically, go ahead and, oops, I don't want to do that. Let me get some room for you. That never works. I get to recreate it up here. Find a range of that function. Wow. Now, if you graph this, you're going to get something like, well, I can either go to the negative 4 and put a dot, or I can go to the positive 4, but this is the opposite of what you think it would be, so it goes here, and it goes like this. What's its range? You got to think about this one, right? As you put bigger numbers into x, what happens to your y value? It's going to increase, right? It may not look like it, but this is going to keep going up, right? Very, 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 very slowly. But my range would be what? Where does it start? 0. And it goes to, how many people had that? Good. You're all smarter than the average rabbit. All right, try that one. Oh, why did I just exchange page? That would have been easier. Absolute value bars. Okay, the range of this one would be, the graph is going to look like, I have to go over here to -6, correct? 3, 4, 5, 6. It's the OV. Those of you that go out to calculus, you'll realize that absolute values have a hard time finding derivatives at the point. This is called a cusp. Those of you that are moving on, okay? You can do calc up to this point and up to this point, but not at the cusp. So, what would the range be? Can you have 0?
Yeah.
Yep. To infinity, okay? Now I'm going to go into a trig world to show you something that has a different kind of range, okay? So, when you graph this on your calculator, let's just do it together. So, I want you to graph the sine x. More than likely your calculator probably will not graph it. Okay, now I want you to hit the zoom button. And go down to number 7. That's called zoom trig. And we'll talk about this later this year. You should get a sine curve, which is very, very important. You don't know there's not, but a sine curve is all over the place. Okay. When I was in the Air Force, when I did radio, we used to say we do a radio check, and a pilot would say he's 5 by 5, meaning the peaks and the valleys and the period and the amplitude were perfect. Okay. All sound usually travels in a sine curve. But if you were to look at this, what's the domain of this? Looking at your graph. Okay, negative infinity to infinity. But here the range is a little different. Let's see if you can figure it out looking at your graph. Okay? What values does it stay between? Negative 1 and 1. Okay? Now the question is, does it equal it? And if you get on a test or an ACT test question and you're confused, just go ahead and put in, let's see, it's going to hit it. Go ahead and put in your calculator the sine of 90 degrees. And what do you get?
It goes at 1.
Goes to 1?
Yeah, it's just
Okay.
straight line.
So then what does it equal 1 then? Then you have 1. Okay? So these are brackets. You won't see it in my class for a quiz or anything, but those of you that might be retaking the ACT, you may see that. What's the range of this? Have you taken an ACT recently?
Yeah.
Do they have domain and range in there?
No.
Oh, nothing?
No. Nothing like this.
They didn't have any domain.
I don't think so.
They had to have some.
No. Yeah, but nothing.
The crazy thing is the MCA has it, but the ACT doesn't. Sure wish they would combine the two together. That's a rant for a different day. I don't want that one on